Auzubillahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I'm your teacher today again here for Sound and Hearing, chapter number 7, part 2 lesson. Okay, so far we have learned about sound energy. We have learned about that sound is always produced by vibrations. Then we have learned about the types of, or you can say the nature of the sound waves, that they are longitudinal waves. Then we have learned about how sound travels. Okay, then we have learned about how the bell jar experiment works, and we have learned about the speed of the sound and echo and the uses of echo. So those who have joined late, please go through by all the Zoom recordings which has been uploaded on the Google class, so that you will update your knowledge about this current chapter, and next time uh, join Zoom classes on time for every subject every day. Got it? Okay. Now students, let's move to our today's topic. Yes. Today, first of all, we will talk about types of sound waves. Okay. Before that, when we have learned about the type of sound wave, that was telling you about the nature of sound wave. Got it? Nature of sound wave. That the sound waves are longitudinal waves. And in our last lesson, we learned uh, in detail that how the longitudinal waves are produced, or what are longitudinal waves. That are the regular forward and backward movement of molecules, okay, which ultimately makes the waveform. Okay, but today we will talk about that how many types of sounds are produced by different sound waves. Okay, so let's start then. That sounds are produced when objects vibrate. This is a very key point. That's why we are saying it or repeating this sentence time and again. Because without vibration, there is no concept of sounds. Remember, okay? So the bigger the vibration, over here we will call it amplitude. Inshallah, later we will talk about what is this amplitude. But it says that the bigger the vibration, the louder the sound. Okay, now keep this point in your mind, that the more the vibrations, bigger the vibrations, the louder the sound will be. Got it? And then a very, very important today's term is that the number of waves per second is called the frequency. It is called as frequency. Okay, I will talk about it later. So the higher the frequency, the higher the pitch of the sound. So over here, I'm just introducing some terms that how vibration, amplitude, frequency, and pitch are related to each other. Okay, so inshallah, we will discuss about them one by one. But right now you are watching, students, that there are many different types of sounds in front of you. Okay, let's see this: loud sound, quiet sound, high sound, low sound, human voice. Okay, so loud sound is basically the, what we said, that loud sounds are produced when there is high or more vibrations. Okay, and what is frequency? The number of waves per second. Okay, you can see over here that over here one, this is called as one wave, and then it is called as the second wave, or counted as the second wave. Okay, so that waves, because they are high up in their compressions and rarefactions, making more movement, that is called as the loud sound, or that is generating the loud sound. Whereas in quiet sound means where is silence or inaudible voice, means you are very having very difficulty in hearing some sound sometimes, that termed as quiet sound. Over here you can see that its pitch is very low. Okay, its pitch is very low. It's moving very, it's taking very less up and down or um, movement of the wave. Got it? So the more up and down it will go, although it does not move in upward and movement direction, but for the wave, whenever we take the name of wave, it is always upward and downward. Okay, so in case of sound waves, this upward and downward movement is basically the pitch of the sound. Got it, students? So this is called the pitch of the sound. The more up it will go, it means the more high pitch it has. Okay, and the low, or you can say there is a lesser height in the wave, sound wave, then it means the low pitch of the sound. Okay, so in the case of quiet sound, we can say that it is having a low pitch. Got it? A low pitch. Okay, now there is difference between loud sound and high sound. Got it? Low sound and a loud sound and high sound. Loud means very, very loud, means which is hitting your eardrums uh, badly, while high sound maybe not giving you an unpleasant feeling, or the unpleasant you can say effect to your ears, but it is high, means look over here. Now you can see, students, in loud sounds you are getting high pitch, but the number of waves are lesser. Okay, but in high sounds you can find that there are not only having high pitch, but a number of waves are passing at a time. Got it? So this is the difference between loud sound and the high sound. Similarly, students, you can see the difference over here about the quiet sound and the low sound. Okay, in quiet sound you are having lesser pitch but more number of waves. Got it? And in the case of low sound, you are having a bit more pitch but more lesser waves are there. Okay, so these two differences of quiet and low and loud and high are clear to you all, I just hope. Okay, and in the end I will give you a review of this human voice, because human voice sometimes it is very low, gradually and according to the situation it becomes loud or high, and then again it becomes somehow quiet, silent or low, and so on and so on. So there is much variation in the human voice. Inshallah, today we will also talk about the range of hearing the sound in different organisms and situations and things. Okay, okay, I hope it is clear to you, to everyone. Now move to the next. Then I just took the name of pitch, frequency and hertz. Okay, so what is this pitch? Pitch is basically frequency. Okay, what we have just learned, what is the pitch? The higher the frequency, the higher the pitch. And what is frequency? The number of waves per second is called as the frequency. So pitch is basically equal to frequency. The number of wavelengths, we have already learned about this wavelength in our previous lesson. What is wavelength? Yes, anybody can recall that it is the distance between one compression to another, or distance between one rarefaction to the other rarefaction. Okay, so the number of wavelengths passing a point every second is called its frequency. Okay, students, the number of wavelengths कितनी वेवलेंथ्स गुजरती हैं एक पॉइंट से हर सेकंड में, वो उसकी फ्रीक्वेंसी कहलाती है. एंड वी measure it in a unit which is called as hertz. What it is called as hertz. So you can see, student, that in this diagram, when I say that it is a low sound, you can see that in the case of low sound, only one wave has been passed. Okay, so low or longer the wavelength, or you can say it is having only this much length, having much length, it will have the lower frequency and lower pitch. In the case of high pitch or high frequency, dear students, you can see that the wavelengths are shorter, means they are not only shorter, rather they are more in number. Okay, so I hope you are getting the point that longer the wavelengths and lesser the wavelengths, lower the frequency, lower the pitch will be. More the number and shorter the wavelength, the higher the pitch is. Got it, students? So pitch is basically determined by the wavelength. Okay, so this is telling me that only one wavelength is there. So longer the wavelength, it is also longer in size and lesser in number. So its pitch will be lower. Yes. And if shorter the wavelengths, these are the shorter wavelengths because they are very close to each other, and more wavelength or more waves are passing in a second, higher the pitch will be. I hope this is clear. These are interrelated terms with each other. I again suggest you to go through by these terms again and again to make your concept clear. And still, if you find any difficulty, you can contact me. Okay. So again, we will talk about the frequency cycle. Okay, students. So now look into this uh, picture, that see, student, what is counted as one cycle or one wavelength. You can see over here that from traveling or starting from here, making compression, in other words, and then coming back till there, making a rarefaction. So a consecutive compression and rarefaction makes one cycle. Yes, students, makes one cycle. So what is frequency? That cycles per second, means in a second, whatever number of cycles will pass will make the, or will be called as the frequency of that substance. Are you getting my point? That how many cycles have been passed per second will make the frequency of that substance. And it is measured in hertz. This is the unit of frequency, and it is symbolized as capital H, small z. Remember, capital H, small z. Now giving you a more clear concept that this frequency can be different or vary in within one substance or a situation. Okay, now listen it carefully, that when you pluck the top string of guitar, okay, you know what is the shape of guitar, and you are plucking it from the top side, it vibrates 660 times a second. Okay, it vibrates 660 times a second, means in a second 660 cycles, 660 cycles have been produced in a second. So the frequency is called as 660 hertz. But students, when you pluck the bottom string, means within the same guitar, now if you are plucking from the bottom, it vibrates only 165 times a second. Okay, 165 times a second. So the frequency will be 165 hertz. So the higher the frequency of a sound, the higher its pitch is. So definitely, students, because here more frequency or higher frequency is there, means at the top part of the guitar, it is having more frequency, it will produce a higher pitch. But when you will pluck at the bottom, it becomes very less as compared to the top string. So the frequency and the pitch will be lower. Okay, so you have I hope that all of you have listened the musical instrument. So within the same musical instrument, sometimes it gives you a high sound, sometimes it is giving you a low sound, low note. So it depends upon the frequency, upon the cycles, frequency cycles, that in a second how many frequency cycles are being produced. More frequency cycles will be produced, it will produce a high sound with a higher pitch. Wherever it is having less frequency cycles within that musical instrument, or even with human voice, it is having lower sound at the lower pitch. Got it, students? I hope that now your concepts are more clear. Got it? Okay. Now moving to the next, that yes, very important, range of audible sounds. Audible means which can be heard. Remember what it is. Audible means which can be heard. So there are two ranges of audible sounds. Okay, students, one is called as ultrasound and the other one is called as infrasound. Okay, what are they? Ultrasound and infrasound. What is the infrasound? Sound waves with a frequency too low for the human ear to hear are called infrared. Means the key point for this ultrasound is the human ear. Means if the human ear is not able to hear a sound because its frequency is too low, we will term it as infrasound. But sound waves with a frequency too high for the human ear are called ultrasound. Sometimes the sound is too high that we put our hands uh, on our ears because we cannot bear that high sound. It happens, I hope every one of you know. Sometimes the sound is too high that we unconsciously put our ears on put our hands on our ears. Okay, so that type of sound is called as ultrasound. So here students, they have given you a range. Okay, they have given you a range, and remember the standard of all these um, sounds range is human, because these all standards, all these ranges have been made according keeping the human ear as the standard. So the sound which is below 20 hertz, okay, below 20 hertz over here, what it means, students, I will again repeat. It means that in a second 20 frequency cycles or 20 wavelengths have been passed. So if they are in a second below 20, your ear, means a human ear, cannot hear that sound. A human ear can hear the sound which is between the range of 20 to 20,000 hertz. Got it, students? What it is? 20 to 20,000 hertz. That sound, that frequency is audible for human ear. Means human ear can hear the sounds which are ranging from 20 to 20,000 hertz. And if it exceeds 20,000, it becomes ultrasound. Even in that case, a human ear cannot hear it. Okay, cannot hear it. So adding up to your knowledge, you can see that animals such as whales, elephants, and hippopotamus use infrasound to communicate over distances. Okay, so these type of animals like whales, elephants, hippopotamus, they use infrasounds, okay, to communicate. While the animals such as dogs, bats, birds, and insects can hear ultrasound. They hear too much high sound. Got it? So again, ultrasound is high frequency sound above 20,000 hertz, too high to be heard by humans. Ultrasound echoes can be used to measure distance, that is sonar. Do you remember, students? In the last lesson, I have told you about the echolocation, and this sonar is basically the special instrument which is present at the bottom of the ships and which helps to find out the things or the hindrance in the sea water. And to see the inside objects means it scans as well. Okay, so these sonars are basically fitted in the submarines or the ships. Infrared sound, it is the low frequency sound, inaudible to human, means a human cannot hear it, although we may feel very slow vibrations, means something must sense our ear, but still we are not able to hear the sound properly. And last but not the least are the earthquake waves. You know, when it is earthquake, it's having a much explosion and exploding. They are a form of infrasounds. Yes, they are a form of infrasounds. Elephants and some other large animals can hear infrared sounds as well. Got it, students? I hope that your concept is clear up till this topic, range of audible sounds. Okay, moving to the next topic now, loudness and amplitude. Okay, do you remember that in the start I took this uh, name of this term amplitude? Okay, so this amplitude is basically related to the loudness. What is loudness? The loudness of a sound increases with the amplitude of the sound wave. And what is amplitude? Amplitude is basically loudness. Loudness is basically the volume. That's why we have a special term or special device in our sound systems, and that is called as amplifier. I hope the boys knows well about it. The amplifier, that is a special device which is present or attached with some sound systems. Why it is present? It increase the loudness of that sound system. Okay, again, more amplitude, more louder sound you can hear. Got it? And this will make the or decide the volume of any substance. Got it? So higher amplitudes are interpreted as a higher volume, hence the name amplifier for a device which increases amplitude. That's why this for increasing the volume of a sound system, we use the device, and that is called as amplifier. Got it? Okay, moving next to it, seeing sound. Yes, can we see the sounds? No, we cannot actually see sounds, but with a microphone connected to an oscilloscope, we are able to watch the sound waves. In real, we cannot see sound waves. But if we attach a microphone, I hope every one of you can see over here. If we attach a microphone with this special instrument, which is called as oscilloscope, we are able to see the sound waves on the screen. And from here, we can decide even that what type of sound is being produced. Either it is a loud sound, quiet sound, high sound, whatever we can determine. So it can show sound as waves on the screen basically. When you speak out in the microphone or you attach some instrument with this, connect any other instrument with this microphone, the vibrations are changed into electrical signals, and these electrical signals are then can be observed on the screen of this oscilloscope. Okay, so the oscillations, what is oscillation? We had learned about this term even before. That is the regular forward and the backward movement. Okay, so the oscillation uses these to produce a wavelength, that how what type of wavelengths and how many wavelengths have been passed per second. Then we can determine the frequency of any substance particularly, and only in this way we are able to see the sound. Coming to our last topic of today, that is the wave equation. Okay, students, so the relationship between the speed, frequency, and wavelength of a sound can be shown by an equation. Speed means speed of sound over here is equal to frequency. What is frequency? The number of waves passing, sound waves passing through or passing in a second. Okay, that is called frequency. I'm recalling it again. Multiplied by wavelength. And what is wavelength? The distance between one compression to the another compression, or distance between from one rarefaction to another rarefaction. So speed is measured in meter per second, frequency is measured in hertz, and wavelength is also measured in meters. So when we generally say that the speed of sound is 330 meter per second, how we actually calculate it? We have used this wave equation. It will get this 330 meter per second value only if there is frequency of 110 hertz with a wavelength of 3 meters. Okay, if the frequency is 110 hertz, means in a second how many waves have been passed? 110. Yes, students. And in what is the wavelength? Means how many wavelengths have been what is the distance of the wavelength? It is 3 meters. When you multiply 110 with 3, you get the speed of sound 330 meter per second in a second. Got it? So this is called as the wave equation. Okay, that is all for today. I hope you have your concepts are clear. Still, if you find any difficulty, please, I always welcome you to ask me about your queries. Okay.